Section 7.7 is on applications of rational equations and proportions. So first off is we need to think about solving proportions. So first off, we're going to define those. So definition, we notice that a ratio of A to B is A divided by B, or we'll sometimes write sometimes you'll see it as A colon B. So I don't think your textbook uses that particular notation, but it gets used from time to time. And so the idea of a ratio is just the idea of relating quantities with like units. So things like 3 inches to 12 inches, 4 people to 100 people, or just generic 7 over 12, we notice we have to be a little bit careful when we use that fraction 7 divided by 12. We notice that A divided by B as a ratio is slightly different from A over B as a fraction. So we notice that the ratio of 2 people to 8 people basically means 2 people do something, 8 people don't. So you might say 2 people drink Dr. Pepper, 8 people don't drink Dr. Pepper. So that would translate as a fraction. That translates as a fraction of 2/10. So we notice that that's one of those things where I don't think we're going to have to really deal with that much for this class, but it's something to be aware of if you have to deal with ratios in more detail. This also points out the fact that we notice we can simplify a ratio. If we have a ratio of A colon B, we can write that as A divided by B, and then if A and B have any common factors, if A and B have common factors, we can simplify the ratio. So for example, that ratio of 2 to 8, so if we had 2 people to 8 people, we can write that as 2/8, we can simplify it as 1/4, and then we could rewrite that as a ratio of 1 to 4. So the ratio of 2 to 8 is the same thing as the ratio of 1 to 4. So our other definition is the idea of a proportion. We notice that an equation that equates to ratios or rates is called a proportion. And so this is basically just the idea of A divided by B equals C divided by D. And so we've seen things like this before. So if we saw something like a ratio of 3/8 equals a ratio of 2/7, we actually notice that we can state, when we state a proportion, we can identify it as true or false. And the easy way to tell is just try cross multiplying. If the cross multiplication works, it's true. If it doesn't, it's false. So we notice that A divided by B equals C divided by D if and only if AD equals BC. And so we notice that if we state 3/8 equals 2/7, we check the cross multiplication. 3 times 7 is not equal to 8 times 2. And so we know that this is a false proportion. On the other hand, if we looked at something like 3/5 equals 12/20, now we notice if we take 320 times 20, that is equal to 5 times 12. So actually, let's double check. We notice with the 3 times 7, we get 21 isn't equal to 16. In this case, we get 60 is equal to 60. And so that tells us this is a true proportion. So we can actually make use of that. Solving a proportion is accomplished by solving the rational equation. So an example, if we want a television that has ratio of width to length of 16:9, so standard widescreen format, and the height, the maximum height is, sorry, I should say width to height. So the ratio of width to height is 16:9, and the maximum height is, let's just make it 27 inches. What is the maximum width? So we set that up. We notice we're looking at height to, we know what the height is, so we're saying 27 divided by the unknown width should be 9 divided by 16, because we said that the ratio of width to height was 16:9. Actually, we have to, yeah. So we notice that means that if we could either write it this way, or we could write it as W divided by 27 equals 16 divided by 9. You notice that if we flip both fractions, if we flip both ratios, it's the same proportion. But we have to make sure we flip both. And so you notice if we cross multiply in either case, we're going to get 27 times 16 equals 9 times W, or W times 9 equals 27 times 16. And you notice that it often pays, especially for our questions, to wait on the multiplication, because if we divide both sides by 9, we notice 27 divided by 9 is 3. And that makes our multiplication easier. So we're going to get 3 times 16 equals W, or W equals 3 times 16, and so W turns out to be 48 inches. And so that's a pretty classic scenario. If we wanted something similar, most of these kinds of questions are going to be very similar. We notice that if we had similar triangles, that's another classic case. We notice that similar triangles have corresponding sides with a fixed ratio. So what does that mean? That means that if we had the first triangle has side lengths ABC and the other triangle has side lengths D, E, F, and we know, let's call these triangles A, B, capital A, B, C, and capital D, E, F. If we say triangle ABC is similar to triangle DEF, then A divided by D has to equal B divided by E, has to equal C divided by F, has to equal some constant. And so what does that mean? That means that if we had the first triangle was, say, 3, 4, 5, and we knew that the other triangle was similar, so if we say these two triangles are similar, and we know that this side length is 9, and we don't know these other two side lengths, let's name them E and F just to stay consistent, we notice that 9 divided by 3 has to equal E divided by 4, has to equal F divided by 5. So let's make that two separate things. We can say 9 divided by 3 equals E divided by 4. 9 divided by 3 equals F divided by 5. And you can kind of see where this is going. If we cross multiply, we're going to get 36 equals 3E divided by 3. We get E equals 12. And if we cross multiply over here, we're going to get 45 equals 3F divided by 3. We're going to get F equals 15. So solving these proportions is usually just a question of cross multiply and solve. So you'll sometimes get more exotic cases if we had something like this, where we know we have similar triangles, and we mixed and matched a bit. If we said that's 2 and this is 7, and we said this is 10 and this is, let's make it 65, we notice that this actually points up something else interesting. We notice that we're claiming these are similar triangles. We notice that that means that 10 divided by 2, we'll just name this B, and this we'll call A, B, C, D, E, F. We notice that 10 divided by 2 has to equal 65 divided by B, and so that means that we get 10B equals 130, divide both sides by 10, B would be 13, and we notice that we could say F divided by 7 has to equal 10 divided by 2, so that means that 2F has to equal 70, and so that would mean F would have to equal 35. This points out something interesting, though. We notice that if we tried saying B equals 13 or F equals 35, What's wrong with that? We notice 2 plus 7 is less than 13. So it turns out we can never actually make a physical triangle that has these dimensions. So that means this triangle is impossible. Again, that's not something you're likely to see on an exam question, but it's worth being aware of if you take further coursework in geometry or trigonometry. You'll occasionally come across cases of triangles that are they'll have various labels, but it's really easy to create a triangle that is physically impossible to actually make. So just see a similar example where it will work if we had something like 12 and 9, and we had, let's make it 3 and 5. This should work out okay for us. We notice that, again, we'll just make this C and F, actually C and E. So we notice that C divided by 12 has to equal 3 divided by 9. So we're looking at the corresponding sides. And so we know that 9C equals 36. And so C equals 4. And we notice that to get side E, we know that 9 divided by 3 has to equal E divided by 5. And so we end up getting 45 equals 3E. And so E is 15. One of the other classic applications of this is shadows and ropes. We notice that if we had, say, a tree or a building that cast a shadow, so for whatever reason it casts, we'll pretend, we'll reshape it a little bit to make it a little more diagonal. So you have a tree and it casts a shadow. And we know that, say we have a person who is 6 feet tall. So you have a 6 foot tall person casting a, let's make it a 12 foot long shadow. And we know that the tree, we've measured that the tree casts a, let's make it a 30 foot shadow. We can use proportions to determine the height of the tree. We notice that the person's height, 6 feet divided by 12 feet, has to match up to the height of the tree divided by 30 feet. And so again, we're just going to cross multiply. So we're going to get 180 square feet equals 12 feet times the height. And so this is one of those cases where we don't necessarily need to use the units, but having the units helps to let us know we're doing things right, because if we divide both sides by 12 feet, we find out that 180 divided by 12 is going to be 15. Is that right? Yeah. And we notice that if we think of feet squared divided by feet, that should give us feet. And so the height of that tree is 15 feet. We also notice that we can use this for rates. A rate is a proportion involving different units. And so that's things like miles per hour, miles per gallon, more practical things like people per car. And so we notice that if we know that we can fit 4 people fit in one car, 4 people to one car, we notice that if we have given 96 people, how many cars do we need? And so we notice we're just setting this up as 1 car divided by 4 people equals X cars divided by 96 people. And so we notice we can cross multiply. We're going to get 96 car people. Which sounds funny, but there are units in physics that used to be called foot-pounds. And some people still call them foot-pounds. And so we divide both sides by people. Divide both sides by 4 people. And we find out that X has to be 24 cars. We'll also get some sneakier ones that involve some messiness. Let's grab a fun one. So in order of complexity, we have some that are just notationally more complex. If we had W minus 2 divided by 4W equals 1/6, this basically amounts to being back to the idea of a rational equation. And so we just solve it by cross multiplying. We get 6 times that quantity W minus 2 equals 4W times 1. So 6W minus 12 equals 4W. We can subtract 4W from both sides to get 2W minus 12 equals 0. Add 12 to both sides so that 2W equals 12. Divide both sides by 2, and W equals 6, and we have to verify that 6 doesn't cause any troubles for the denominator, and it doesn't. If W equals 6, we can check. We get 6 minus 2 divided by 24 is 4 divided by 24, which is indeed 24, which is indeed 1/6. If we had something like, so just to see it, I don't think you'll get an exam question like this. This is number 42 in your book on page 555. So page 555, number 42, we have a plane flies 630 miles with the wind in the same time. A plane fly 630 miles with the wind in the same time that it takes to fly 455 miles against the wind. So if the plane flies at the rate of 217 miles per hour in still air, we want to know what the speed of the wind is. If the plane has a speed of 217 miles per hour in still air, how fast is the wind? And so for a question like this, we're relying on distance equals rate times time. So distance equals rate times time, d equals rt, and we can tweak that a little bit. We notice that we know the same amount of time. We can say that a distance of 630 is equal to 217 plus v times time, and we know that 455 equals 217, whoops, we'll put this below, and 455 equals 217 minus v times the same time. So basically we notice that we've got different rates given by the velocity of the plane with the speed of the wind versus the velocity of the plane minus the speed of the wind. And so we can set that up to solve for t. We notice that that means that t has to equal 630 divided by 217 plus v, and it also has to equal 455 divided by 217 minus v. So, because it's the same time either way. So we cross multiply, we get 630 times 217 minus v equals 455 times 217 plus v. So that means we're going to get 630 times 217. So we're actually going to cheat just a little bit. Well, not cheat. We can take 630 times 217 minus 630v equals 455 times 217 plus 455v. We can add 630v to both sides. We can subtract 455 times 217 from both sides. Whoops, 455. And so that means we take 630 minus 455 is going to be 175 times 217. 217 has to equal 1085 v, and we can divide both sides by 1085. So we're probably going to do this with a calculator. We notice that trying to do it without a calculator, we can do it by hand. It's just long and tedious. So we check 175 times 217 is going to be 37,975. And then we divide that by 1085. And that gives us 35. So we find out that the velocity of the wind is 35 miles per hour. Well, the speed of the wind. If you take physics, you'll find velocity and speed are slightly different. Speed of the wind is 35 miles per hour. So like I said, that's a slightly fussy question type that we're probably not going to see on the exam. One that it's just barely possible to see is the idea of combined work. We notice that if two people or machines are both working on the same project, it gets done faster. So one of the classics is if we have Bob can build a bookcase in 4 hours, and Carol can build a similar bookcase in 3 hours. how long would it take them working together? How long would it take working together? The idea is we think of Bob gets 1/4 of a bookcase built per hour times some length of time. Carol gets 1/3 of a bookcase done per hour times the same time. And we know how long it will take them to get one complete bookcase. And so this is again a rational equation. We notice that the easiest way is to multiply both sides by 12. We're going to get 12 times 1/4 plus 12 times 1/3 equals 12 times 1. So that means we get 3t plus 4t equals 12. 7t equals 12. And so t is 12/7. Or we can think of it as being 1 5/7 hours. We also notice that we can tell that if it takes more than 3 hours, something has gone wrong. It should take less than whichever one takes less time. And so what actually happens if we have one takes A units of time and the other takes B units, we can get a shortcut. We see 1 divided by A, t, plus 1 divided by B, t, equals 1. We can multiply both sides by AB. We wind up getting BT plus AT equals AB. If we multiply both sides by AB. And so we find out that T times the quantity A plus B equals AB. And so our shortcut for this process is to say the time is going to be A times B divided by A plus B. And so if we said something like together, 2 printers take 12 hours to finish a job, and one is twice as fast as the other, we can ask how long would each take working alone. And so we have to be a little more fussy with this. We notice that we can set it up at using this shortcut. We can say A equals twice B to see that A takes twice as long. And so we find out that we're going to get that A times B divided by A plus B equals 12, but we can replace A with 2B. So we're going to get 2B times B divided by 2B plus B equals 12. There are several ways we could do this. We could multiply both sides by 3B. This is basically going to be 2B squared divided by 3B equals 12. Multiply both sides by 3B. So we get 2B squared equals 36B. We can divide both sides by 2. We get B squared equals 18B. And then we have a couple ways to do it. The easiest way is just divide both sides by B. Obviously B could be 0, but that causes complications because we're dividing by 0. And so we get B equals 18. So B would be 18 hours and A would be 36 hours. And so that's about as hard as one of those questions will get.